Hello, everyone. I think we're ready to get started. Welcome to Jank Busters. I'm Tom Wiltzius. I'm a PM on the Chrome graphics team.
I'm Nat Duca. I'm a graphics hacker on the Chrome team.
And we are here today to talk about Jank on the web, what it is and how to avoid it.
Yeah, so Jank, everybody has a screen in front of them probably. Jank really begins with the monitor, right? You've got this monitor in front of you, and it's designed to sort of trick your eye into this illusion of motion. And the way it does that is by updating a frame every couple milliseconds, right? And the trick is your eye wants to go at something like 40 hertz. And if you do that, then you'll perceive motion. And so monitors out there go anywhere from 30 to 50 to 60 to 70 hertz, right? And if you manage to get all of your JavaScript and all your different pieces going at that rate of the monitor, then you can present this illusion of smoothness, and then people are happy.
But if you don't manage that, then you end up with Jank. And this is what we're talking about when we're talking about Jank. It's any time that you don't get a new image on the screen every time the monitor refreshes. This comes in all sorts of formats. A hitch is when we miss a bunch of frames in a row. A low frame rate is when you're ticking out a frame every maybe fifth of a second instead of every 50th. Variable frame rate is maybe some combination of these things. And this is particularly painful when you're trying to interact with something. So here's a div with a bunch of Chrome logos moving around, and it scrolls sluggishly. It's what we call a janky scroll. And the problem here is that as I move my finger on the trackpad, I'm scrolling around in this little iframe, but the frame rate isn't matched up to the monitor's refresh rate. And as I move my finger, I don't get the smooth motion on the screen that I sort of expect. And so the physical metaphor is broken, and it doesn't feel good. It doesn't feel fluid.
Yeah, so basically what's going on behind the scenes when you get dropped out of your experience and you get something like Jank is one part of the rendering pipeline is getting behind, right? Now, if you go online and you look at our talk from last year's I/O, and also a lot of great resources out there on Jank busting, you'll find that there's this great feature in DevTools called the frames mode. It's in the timeline, and you can use that to record basically an interaction with your page and see, for example, oh, hey, this frame ran long because of JavaScript. And there are just thousands of things that can go wrong. CSS can run long. You can have an XHR that comes back and does some big JSON parse. You can have an image decode that fires. You can, I can go on for hours on this,
What Nat's trying to say is that there's a lot that gets in the way of the 16 milliseconds that you have to make a new image before the monitor refreshes. And there are, as Nat says, lots and lots of ways that this can go poorly, but today we're going to talk about one kind of specific category, and that's what are essentially the green bars in the vertical timeline in DevTools. This is what we call sort of rendering, but that breaks down into painting and compositing, and we're going to talk about both of those in today's talk.
And it's good that Tom saved you from me yammering on, because you'd just fall asleep and be wasting your time.
So rendering, what are we going to talk about today? We're going to talk about painting speed, what kind of goes into it, and how you can try to paint as quickly as possible. But then, even better than that, we're going to try to talk about how you can avoid painting in the first place, either because you were doing so accidentally and you didn't realize it, and we're going to show you how to notice that kind of thing. And then, better yet, we're going to talk about how to deliberately avoid paints from the get-go when you're designing your application.
And there will not be a rocket ship that we can give you at the end as a takeaway, so sorry. The beginning building block of rendering in a web browser is preparing pixels to be put up on the screen. So if you go to Google, right, we've all been there, you're presented with this, which is the nice little happy hello Google thing, and you get a blinking cursor, right, where the only difference between the page over time is the cursor coming on and off. Now what Chrome's doing behind the scenes is it's actually filling in those black dots for the cursor itself. And what it's doing is it's got some logic in it that says, ooh, this part of the page has changed. I need to refill those pixels with black, or I need to remove them. And so you get this little update rec, this painted area on the screen that we repaint, and then you see this illusion of a blinking cursor. Now, if you think about that, that takes some time, but it's probably relatively little. And if I compare the time taken to blink the cursor versus, say, if I just had the whole Google logo blinking. Now, of course, people would be upset if I did that to our homepage, but also it would take more time to do it, okay? Because you can sort of think about this as intuitive. We have to touch more pixels, right? So that's one dimension of rendering performance, and in particular, painting speed. is how many pixels you've touched. But that's not the only dimension, of course. The other part that matters is what you touch and what type of content is in the area that you're updating. So if you take this white block on the upper left, that's just white. And if you think about what Chrome has to do to make those pixels white, it just has to sort of put RGBA for white into a bunch of parts of memory. So that's a mem set, and it's pretty darn fast. In contrast, the I'm feeling lucky button has all sorts of nasty little details on it. And it's actually kind of fun to zoom in on this on a computer with a magnifying glass and see all the things going on there. If any of you have actually taken like an undergrad graphics class and had to write like a line drawing algorithm, imagine having to do that, but in Chrome, where you also have anti-aliasing and rounded corners and blurs and text and anti-alias text. It gets really hairy, and it's sort of the thing that makes you want to jump off a cliff, but it's also the thing that makes the CPU chug along. So painting is a slow thing, and it's something to be avoided pretty much at all costs.
And you want to wonder probably like what is expensive and what isn't, right? Like Nat's just asserting that like, drawing these anti-alias lines is expensive, but in an ideal world you would be able to measure this kind of thing. And this is something that DevTools does allow you to do to a certain extent. A good question to ask is like, well, which elements on the page are really expensive? And a good way to measure that is with continuous painting mode in DevTools, which is a DevTools setting that we're not going to talk about in great detail today, but there are some really good resources on the web about how to use it. This link and our slides will be linked on the web later. We'll take you to an article that explains in detail how to use continuous painting mode to repaint the entire frame as fast as possible and tell you how long that takes, and then you can hide certain elements and see how does that affect the painting time, because often as not, it's a single complicated element that's taking a lot of time.
When you look at your page, look at all the pieces, and keep in the back of your head that not all of them are the same cost, and you're paying for some of those effects more than others. And if you start getting in a situation where you see painting, start figuring out which ones you're paying for and whether you really want to be paying that bill for that one.
That's right. Painting also, I should say, it's not just about the blinking cursor, right? In the blinking cursor case, it makes sense that we need to repaint like the part of the screen that's changed because the pixel output is different. But there are plenty of cases on the web where even if you change something that doesn't have any sort of material impact on the final presentation of what goes up on the screen, you can still incur a costly repaint. And we're going to show a small demo of that right now. If I hit this button, I get elements that are added to the screen. This is really simple. These are just gray divs, basically styled, right?
Winner of Website of the Year for 2013.
Thanks, Nat.
You're good.
And what we want to do here is get some insight into what is being painted when by the browser. So if we open up DevTools and we turn on Show Paint Rectangles under the rendering heading of settings, then we have the ability to really see what gets painted as the page changes. So again, I'm going to hit this button a few times, and you can see that as I add additional elements, there's a red rectangle that flashes over the element, and that red rectangle means this part of the screen just got repainted by Chrome, or really by Blink in this case.
So that's that rectangle that I was showing you in slides, but in runtime for your production site.
That's right, and I can keep adding elements, and now I'm adding elements like way below the fold of the page. And you can see that as I add more, the only thing that gets repainted here is the button, because it ends up in this depressed state and then comes out of it, and the scroll bar, because the scroll bar size is changing. So this is great, right? And it makes sense in some sort of basic logic that as you're adding elements below the fold of the page, you're not having to repaint anything that is on the page. But it's not always that simple. If I try to do something like inspect this container block, and the DevTools inspection is going to drive the paint rectangles nuts a little bit. But if I look at this block that contains all of these elements, and then I toggle, say, how much padding there is on the right side of that container block, I'm not going to end up with any, again, visible change to what gets rendered. These divs are sized such that even if there's an extra 10 pixels of padding on the right side of that container, the layout's not going to change. Nothing's going to look any different. But watch what happens when I add some of that padding. You can see it's probably small text, but padding has showed up in the element style and inspector, and I got this big red rectangle that flashed over the entire container. And the reason is that Blink, I mean, it's not that smart, right? And so when some of this padding got added, there was a series of steps that it went through that said, okay, now I need to think about, do I need to recalculate the position of any of the elements inside of this container block? The answer ends up being no, but in the process it invalidates the sort of visible state of all of these elements on the screen, and then they all get repainted.
Yeah, Blink has a well-meaning but sometimes confused brain. And so, in this case, it's getting confused. It thinks that maybe something bad's about to happen, and it causes a repaint. And this is the sort of thing that actually happens more often than we'd like. When you use and write really nice modular code that's beautiful and has all sorts of awesome design patterns in it, sometimes this sort of thing will creep in because somewhere deep in there, somebody added a class and then removed a class somewhere else, and that confused the system. So this is something to keep your eye out for when you're doing sort of day-to-day production. Keep an eye out for these erroneous blinks where you would expect there to be no red flash, and there is. Because once they start creeping in, they're really devilishly hard to stamp out again.
It's very true. And so switching gears a little bit, we've talked about painting now, but the next best thing from trying to avoid unnecessary paints is to not paint at all. And Nat's going to talk a little bit about how we do that for common cases like scrolling.
So like in ye olde days, right, like 1990 something, the way that we would scroll a page in a browser was we would repaint parts of it. So we would move bits of the pixels up using some low-level things, and then we'd do a big repaint rectangle on the area that you'd exposed from the scroll. Now, we just talked for a while about how devilishly slow painting is and how it should be avoided. So developers in both WebKit and Blink and Chrome and pretty much everywhere have adopted this new notion of a layer. If you look at this picture we've got up of Gmail, the analogy is this. If I look at Gmail, I know that there's a part of the page that's just going to move up and down. It's not going to change visually. It's just there are going to be new pieces shown that weren't previously visible. Right? But the stuff on top of it, the top nav and the left thing, they'll always be there. And so there's this sort of idea of, hey, we will detect that using semantic cues in your thing, like it being an overflow div, and we will turn those into layers. And each layer becomes a picture that we upload to the GPU on your computer, store there, and then if the thing that you're doing to your page is just moving the layers around, we can ask the GPU to scroll it for you, or in fact reposition it and then ask the GPU to recompose them. And so it looks like you're scrolling because you're only looking down at the layers. You just see it, it looks like your same old web page. But what's happening underneath is the browser is just recompositing, skipping that expensive paint step and going nice and Jank free. But this all depends, this Jank freeness is all predicated on you getting good layers in the first place. And if you don't get those layers created, things can go a little bit haywire.
That's right. It's also predicated on not like the good layers. It's predicated on the layers being set up in such a way that we don't need to paint them, right? Like if the layer content is changing, then all bets are off on this being a good system. So I'll open up another demo, and this one, maybe it'll load. You want to turn off?
I will turn off Wi-Fi.
Wi-Fi and try again. In a case where we scroll, in this case, a whole long list of images, we can do that pretty well, right? Nothing on the page is changing here. This is a really simple sort of like static media site scenario, and indeed, we can scroll this quite well. This whole sort of body of the page is in a layer. It's being recomposited every frame.
We shall bless this Jank free.
Right. But if I open up DevTools again, and I turn on Show Paint Rectangles, as I had, then you can see that part of the kind of Jank freeness here is that nothing is being repainted. The only thing that's being repainted is, again, the scroll bar, which we can kind of afford.
So we're keeping that contract with the browser. I won't repaint, and you'll be Jank free.
That's right. But if I hover over this image, I've got actually kind of like a nice animation that happens. I add a shadow, I change the opacity, I brighten the image a little bit. This is the kind of thing that's become increasingly common. And as I do that, you can see that because it's sort of a complicated animation that Chrome doesn't accelerate very well, I get a lot of repaints throughout the course of the animation. And that's those red rectangles flashing over the image again. But that animation is going to play really, really poorly with the scroll. And you can probably guess why by now, based on everything we've just said. the browser is going to start repainting to run the animation right at the time when what it wants to be doing is recompositing this static, unchanging content over and over again in different positions. But if the content's changed, then it can't just reposition it. It needs to repaint it first, re-upload it to the GPU, and then recomposite it. You lose all the benefits. And indeed, if I try to scroll with my mouse over here, the resolution of this screen is hurting me a little bit, but it gets a lot jankier. And you can see that there are these big red flashes that occur all over the page, and that gets in the way of a sort of jank-free scroll.
Yeah, so these big red flashes are your warning to, your one-way trip to Janktown, right? You've got big red flashes, and you're basically going to start repainting all the time, and then on a low-end machine, this is a MacBook Pro, so of course it's going to be in better shape, but on a lower-end machine especially, you're going to really start paying dearly.
And this is the kind of thing we see as particularly painful on like phones or tablets. In this case, I mean, getting rid of the hover effect is a relatively simple task, right? So if I uncheck this box, there's a scroll handler here that will disable the hover effect when it first runs and then sets a timer, and 200 milliseconds after the final on-scroll event, it'll re-enable the hover effects. This means that I can start scrolling and the hover effects get disabled and no repaints happen during the scroll, but then as soon as the scroll is done, I still get my sort of nice animation.
And this is sort of your instant recipe to making it smooth, right? Is if you are willing to compromise on some of those gorgeous hover effects or whatever it is that is causing your repaint in the first place, if you're willing to reduce it during the scroll or simplify your content in some way, you can go nice and fast again.
That's right. I mean, this is changing the behavior of the page, right? And that's not always going to be acceptable to you. So it's important to understand that there are often trade-offs between how well something performs and what it looks like, but it isn't always going to be possible to achieve whatever sort of like crazy effect you want in a totally nice performance way. We're sort of picking on hover here, but really there are all sorts of things that can cause this sort of problem. The real thing you want to do is use show paint recs to sort of look for these big red flashes during your scroll or during your animation, and then try to get rid of them. So hover effects are one thing to look out for, but there are a lot of others as well. Common problems come from fixed position elements or overflow scroll divs or touch listeners, mouse wheel events, trying to reposition things in an on-scroll handler for like parallax effect sites. These are all things we see that like really kill performance.
Social widgets that you position when people hover over an article and stuff like that. Like give the page a chance to settle before you bring in your +1 button, right?
Right, which is not to say that like these things are bad, right? It's just that you need to be aware that in sort of liberally using them, you may end up in a position where you really end up fighting with the rendering system and performance is going to go through the floor. There are cases where you really do need that paint, though. You really do want something to change during a scroll. And that's fine. If it's fast enough, it can still be jank-free, right? But you're going to have to be very vigilant about keeping paints as cheap as possible. For this, you want to be paying a lot of attention to how visually complicated your CSS is, and continuous painting mode that we plugged earlier is a good way to try to reduce the cost of a lot of those paints. Image decodes and resizes can be really painful. If you're on a media site with tons of images, you can blow the image cache inside of Blink, and that can be really painful,
Constant vigilance.
Constant vigilance is the answer, yeah. But now Nat's going to talk about some of the other great applications of layers.
Well, I think we got another demo for you, which is always fun, more fun than us talking. But here's the thing: we showed you how you can use layers to scroll smoothly, right? And you can sort of understand that we're moving something up and down. But people like drawers and hover effects and slides that zoom in from the left, right? And this is a really cool thing. There are some amazing things you can do here, but the way to make it fast versus the way that you can code it up quick are often not well aligned. So it's very important when you do sort of animations to also think about layers and also think about how can I construct this animation so that it plays well with Chrome's layered rendering model, not fights against it.
Right, and a lot of that comes down to how can I run this animation without incurring any paints. So here's a really simple drawer. This is styled like incredibly plainly, but you can see that if I open up DevTools and I have show paint recs on, that as I run this animation, which is a simple CSS animation on the left property, right, like very basic, I get repaints of the drawer throughout the entire animation. That means every frame, this entire part of the screen is being repainted, re-uploaded to the GPU, and recomposited. And that's, again, relatively painful.
And if you take that to a low-end device, it'll be worse and worse and worse. 6 times worse often.
Right. So the question you want to be asking yourself is like, okay, well, how do I get around this, right? Like, how do I avoid these red rectangles? And it so happens that one good way to do so for moving things like this is with transforms, CSS3 transforms, rather than changing the position property. Transforms take elements out of the flow of the page, which gives the browser some stronger guarantees about what it can move without risking having to reflow other elements.
So this is an example of not all, you can make the same look in CSS with different types of selectors or different types of attributes and get the same visual look, but it's going to perform totally differently.
Right. Chrome has all these fast paths, but you kind of need to find them, which can be painful. If I use a WebKit transform here and a translate X, I have this comparatively much nicer animation, right? You can see that it's a little bit smoother if your sort of eye is attuned to it. But the really nice thing is that I'm not getting any paints, right? Like, there are no red rectangles throughout the animation. There are red rectangles at the beginning and end, though, and we're going to talk about those next.
Yeah, like if you get somebody who stamps out that first bit of animation and Tom comes over to me and says, I got it. We just have red flashes at the beginning and end. That's not good enough. Never, ever paint. That's what we're looking for. Not, oh, I reduced it a bit. It's don't paint.
Right. And so we're standing up here stating that this thing is now fast because it's in a layer, but you shouldn't take our word for it. You should want to look for this yourself. And the way to do that is to open up DevTools again, turn on Show Composited Layer Borders in DevTools settings, and if you look really carefully, I'm going to zoom in here. There's like an orange border that goes around the edge of the page, and that orange border is your cue that says the content inside of this border is in its own layer. And you can see that there's only one orange border. I mean, it's probably hard to see from the audience on this screen, but
trust us.
there's only one orange border on this particular page because there's only one layer, right? But again, look really carefully, and I'm going to zoom in again. Look really carefully at the edge of the drawer as this animation runs. You can see that there's another orange border that pops up along the edge of the drawer during the animation. And that's your sign that says, oh, this content actually got promoted to its own layer, and now it's being moved back and forth, which is great. But the question is, why the red rectangles at the beginning and end? And if you look carefully, maybe you can guess why. There isn't an orange border before or after this animation runs, right? So what's happening is that the layer that the drawer is in during the animation doesn't exist before or after the animation, right? So the animation starts, we pop the drawer out, put it in its own layer. It's a new layer, so we need to render its contents, right? That's the first red flash. Then we recomposite it, move it all the way over, and then pop it back into the base layer. When we pop it back into the base layer, well, the base layer has changed, right? So we need to repaint that part of it. That's the second red flash. So how do we avoid this? Well, one way is sort of incidental, but if you use a translate 3D instead of a translate X, you get a layer even when the thing isn't moving, because it will be promoted to a layer not due to the animation, but due to the CSS transform itself. And if we try that and run this animation, you can see that I can now run it back and forth, no red rectangles.
Yeah,
right?
look mod, no red flash, right?
And that's great. That's kind of what we want. And if I open up the timeline view, we talked about vertical timeline earlier. Usually you would see all sorts of paint events and stuff, right? But if I start a recording and run this animation, you can see that throughout the animation, all we get are these composite layer operations over and over and over again, which are comparatively super, super cheap. And that's really good. This is like the ideal timeline case, where yes, things are moving, but there's a minimum of other stuff going on. So that's drawers. But sometimes this isn't quite enough. Sometimes just seeing those borders isn't enough to tell you really what's going on, especially if you have really complicated animations, et cetera. Like, these are sort of contrived examples, right? And it's really easy for us to come up with a demo that shows this kind of thing off. But if you're trying to debug a site or an app on a phone in production, there can be lots of stuff going on. There can be all sorts of layers all over the place, and you can be trying to add more, but that's only causing you to have too many. Maybe you're running out of memory. All sorts of things can go wrong, right? And so Nat's going to talk a little bit about what to do in those more advanced scenarios.
Yeah, so what we're going to do now is we're going to take the covers off of an internal tool that we've been developing in Chrome to show the nasty inner guts of the compositing system, which is this thing that makes things jank-free. Now, as you see this, keep in mind that basically this is very, very brand new, and it's designed for developers first. But we wanted to show it because this shows you exactly why things really are slow. The way it works is you get a relatively current build of Chrome, and that'll probably be like Friday's build, not today's. So that's how new it is. And you pop over to your site that you think is janky. So I'm going to just start with something really simple. This is just a tall site with some A's in it, right? Really bringing out the good content for you guys. But remember we showed you the picture of Gmail, right, with it broken out into layers. So what you go is you go over to tracing, this Chrome tracing thing, and you start at recording. You go back over to here and you do your thing, whatever that thing happens to be. So just like in timeline. And what you're going to be presented with once it does its thinking is something that should actually remind some of you of Android systrace in sort of appearance. What you're seeing here is these are all the different times my finger was moving on the trackpad, causing it to scroll. And the nice regularity of that should scream out jank-freeness right away. Each one of these green dots are the things you really want to click on, right? Everything else is sort of sideshow. The green dot represents Chrome drawing one frame up onto the screen. And that's kind of where the meat is. Down here you've got, in the center here, you've got a list of the layers that were on the screen on that frame. There are two. There's this one, which is shown over here, and you can sort of see that's the really tall page. And you see it's the whole darn page. And then you've got this thing, which is tall and narrow. What is that?
It's the scroll bar.
It's the scroll bar, right? It's that little thing, and even on Mac we have it, even though it's transparent. So that's sort of the shape of the page. And then the thing that you want to then look at is, as I go from frame to frame, see this thing over here, this is our mini map. And as you go from frame to frame, you see the green thing, which is the layer, moving. And that's the scroll happening. The blue represents the viewport. So just like in the Gmail example where we showed the Gmail thing, the mail list moving, and sort of this hole where the viewport was looking, this is the same thing, but for my live site. So this is kind of, you can sort of start thinking, this is kind of useful. Hey, that's a big picture. I wonder how much memory it's using, right? And we've had a lot of people sort of worry about that, where they say, hey, these layer things are great, but they're eating a lot of memory. Well, you can actually click now on this, and you'll see the actual bytes consumed by that layer. It's like 7 megs, something like that. And I'm beeping. That was fun. So that's the most fun part of the talk. So you can actually get the actual memory consumption from this tool, which is super useful when you're trying to take your site, which is very layer heavy, for instance, and bring it to a phone, which is constrained. So remember we had this demo up, right? This drawer, and Tom was saying, trust me, there's a layer there. Don't trust, measure. So we're going to reload. I'm going to set it to do that thing where it was popping in and out, and we're going to do the effect. Same old thing. And we wait for it to do a bit of a think, and you can see again there are these 2 big bursts of animation, which is when the rendering system was active. And when I click here, let's pick that frame, you can sort of see this, right? There's my page as before, right? There's the drawer on the left, and then there's this big stall here. It's jank. And when I click here, you see that it's gone. There's a hole. Where did it go, right? And now you see that there are 2 layers instead of 1. This is the root layer, and that's this newly created one. And that got painted. We paid to paint that and pop it out. And we also paid to paint the other layer and to create the hole. And now you see on the left in the mini-map, that drawer is starting to slide in onto the viewport, right? So now it's sliding in, and it's good, and we're happy, and it's 60 hertz, and it looks smooth. And then toward the end, what you're going to see is it smooshed down. So here, from here to here, you see that we have 2 layers, like this still. And then in the next frame, it's smushed down to 1. Right? So then we paid yet again to paint it, and we didn't pay so much of a painting penalty this time, but maybe on a lower end device we would have. And if you scroll down, you can actually see the painting activity taking place. One other final thing to show about this tool. A lot of people wonder, when you get a big site, big production site with a zillion things going on, you get a ton of layers, and you're like, I didn't ask for this. Why is this layer promoted? So if you actually look down at the bottom of this thing, you can see this compositing reason. And so this says no promotion reason given, because it's just the root layer. But if I click on this one that's moving, it's using accelerated animation. And that is your key to then start understanding, hey, maybe I should keep this promoted for some other reason too, so that it stays promoted afterward. And so when we turn this on and do a trace of this with the real that final demo that we said was Jank free, you'll see that that then has several promotion reasons that keep it promoted the whole time. So this is sort of the quick glimpse into a tool that we're trying to get out there into people's hands so that when you're really under deadline and you need to make something Jank free, that's available in your arsenal to sort of help with.
That's right. It is, as Nat said, like super new though. We have some nascent docs up at this link, and we do encourage you guys to maybe in the next couple of weeks go try it out as it lands and starts to stabilize. But for sort of advanced use cases, this is
you can get very far with dev tools. So this is if you're in a pinch, you can check this out. You'll be confused, but it'll help.
That's right. But for starters, as you sort of begin down your journey towards fighting Jank, you want to use DevTools. You want to turn on Show Paint Rectangles every time you see Jank sort of crop up in the wild, and you want to look for what is repainting and try to figure out why. You want to ask yourself, why am I repainting this? And can I either avoid it by just being very judicious and not changing style when I don't have to, or by using layers or some combination of the above? And if you can't avoid it, then you want to make it as fast as possible using something like continuous painting mode that we talked about earlier.
Yeah, there's a lot of great tools, and the thing to keep in mind, if you walk away with sort of nothing else in your takeaways, is this: all the browsers basically are building something around layers. Think about doing your effects, your awesome, immersive web experiences in terms of layers. Think about whether you're designing for that. Try to reduce paint, and if you do, the browsers will pay you back in scores with Jank freeness, smoothness, right? And if you don't, then you're going to be fighting the browser, and it's going to be doing its best, but you're asking it to do a hard thing. So, happy Jank busting.
Yeah. I think we're going to take a few questions because we have some time left. But if you're hungry for more, we've got sort of a collection of links and articles and whatnot up at jankfree.org. It's just sort of a dumping ground for us, and that's where we're going to put these slides as well. So if you take away one URL from this talk, it should be that, and you can get to everything else from there. HTML5 Rocks is the Chrome Developer Relations website. I've written a couple articles there, and we're going to continue putting up content about this kind of topic. So you should definitely go check that out. Our contact info is up here too. We're happy to talk about things like this if you have interesting cases that you want to sort of bring to us. We also welcome bugs on the Chrome bug tracker. And with that, I think we're going to take some questions. So thank you very much.
Hi.
Yeah.
So it seems like layers are really important, but right now it seems like you kind of have to do a snake dance to figure out or make something into a layer.
I like that expression.
Does it make sense for there to be an explicit, style declaration to say, hey, I know how I want to composite my page.
Right. Let
me turn this into a layer, just like WebKit layer or whatever. Make this into a layer, almost like Z-index, right? Is that coming or?
Well, right. No, I mean, it's a good question. It actually comes up a fair amount. It's something we've resisted because, like, in general, there's resistance to adding API surface. But
one of the great things about the web is that your content can run pretty much anywhere. And remember I showed you in the demo that these layers take memory? If you start telling Chrome to use a layer for that, then you run into this situation of it might fit on your high-end computer, say a Pixel, but then it won't fit on an Android device. And at which point, what are we to do? If you start making assumptions about this definitely being in a layer, and we can't fit it in memory, what are we going to do? So I totally get where you're coming from, and this is something that we as a community, the web community, need to really tackle in the next couple years, of how to improve the statement of intent. But we also have to think about, as we do that, how to make it work and preserve sort of that promise of the web where it just sort of works everywhere. Does that feel responsive?
The intent point is a good one, right? Because, like, in some ways, the layer concept, like, it's kind of an implementation detail, and that's not the kind of thing we like to codify with syntax, right? Instead, what we want to codify is stuff about intent, right? So things that, like, for instance, the Chrome compositor is good at right now is moving stuff around, changing opacity, and sort of doing this 60 times a second. And there actually are semantic ways of declaring all of these things, and if you declare them, Chrome will do the right thing, right? Like, those things get layers and those things get hardware accelerated. And so I think that's probably more the direction we want to go, because otherwise you're going to end up trying to, in some senses, abuse it, right? And like you're going to try to trick the compositor into doing things that it's not really designed for. And I wonder, I don't know, but I wonder if we'll end up in a worse place if we kind of go down
TLDR, hard problem, and if you have any brilliant observations, come grab us.
Sure. We're going to be in the Chrome performance area later too, if anyone wants to talk. Yeah, in the front.
Yeah.
I was just wondering, like, if this tool is available on Chrome or Android.
Sorry, can you repeat the question?
Is this tool available on Chrome for Android?
The trace viewer
last one?
will work on
last one.
Android eventually, yeah.
Yeah, all the DevTools stuff, yes.
Yes.
The last sort of advanced tracing tool doesn't work yet, but
It'll come.
It should.
It's all sort of common infrastructure.
The basic tracing does work on Android. The more advanced features to view frames doesn't
I
work.
haven't
there
tried
yet.
it. Might work. We'll see. But it's all one big happy family. We all think about all platforms.
Yeah, we work across.
So if it's not working today, it'll be working very soon, because we want, our whole vision here is you write your web platform thing, and we'll take care of all your OSs for you, modulo a few details.
So instead of asking for a layer, is there a possibility of getting like an experimental no paint attribute on our suppress paint while we move stuff around? Because sometimes you do have, it's kind of like you have to hold the old style TV antenna up to get the right, it's like, did I do the right thing, to kick the compositor just the right way? But if we had a attribute that said, seriously, we actually know better than you, don't repaint this, it might help some edge cases.
There's a proposal floating around for, I believe we're calling it pre-painting. And if you look on one of Chromium's graphics development mailing lists, you'll find a discussion about it. And I think we intend to broaden that discussion in the coming months. But this is about being able to say, hey, I'm bringing in, so think about infinite scroll. You're adding elements to the bottom. Hey, Chrome, or hey, browser, I'm adding this image, but like if you can't put that up in time, no big. I'll put in a placeholder or something. So hey, this is optional, and please let me know when it really is there so I can get rid of my placeholder asset. That's being discussed. I think it may be abusable for the other things that you're thinking about too. That actually feels relatively within scope of the platform, I think. We'll see.
I think there's also room to do that kind of thing higher up the stack before we talk about painting. Like really what you want to do is sort of make a promise to the browser that you're not going to do anything that's going to manipulate style or layout inside of sort of a container block. And if you can do that, then like further down the stack where we're talking about, then we can do the right thing and not paint. But there's some efforts going around things.
There's a lot
like
of discussion here, so we're definitely, and please come on up and we can chat if you want. There's a lot of discussion in the team about how to basically say to the platform, hey, I solemnly swear I'm up to good. Now get out of my way.
Okay, great.
We know it's not good enough yet.
Yeah.
And any love for SVG, Jank-free SVG anytime soon?
Oh, totally.
Definitely. One of the people helping build that tool that we demoed is one of our SVG awesome peoples.
Yeah.
Definitely important.
Summary is yes. It's a little harder because of the way SVG works, but we'll gloss over that. In the front?
Jank-free is awesome, especially considering how poor performance still is 6 years into smartphones on smartphones.
Totally.
But I can't help but look at these demos with, oh, make this a translate and then make this a 3D translate, and think about people who used underscores for their CSS variables to make IE7 not look at that one and look at a different one. It feels like we're introducing yet another web development snake dance, and I wonder if there's anything we can do to mitigate that, to think about our code bases as something that's going to live for longer than the 6 months that I'm on this project, and make it easy for people to maintain down the line.
Absolutely, and I mean that's kind of the reason that we were saying what we were in response to the first question about like, oh, can we have a primitive for like layer promotion? And the reason that there's hesitancy to do that kind of thing is because, again, so directly targeting implementation details of the browser, you end up in a world of pain later where like, oh, I don't really care about whatever IE7 so much anymore, but now my code base is all kind of split up because of that. And that's the kind of thing we don't want to do. We want to stay as semantic as possible so that future versions of the browser don't need to handle these kind of weird cases that were targeted very much at implementations.
If there's one thing to keep in the back of your head, it's this. Probably for the next couple of years, it's going to be messy. And so having your infrastructure on your project be set up to deliver custom CSS or in some way handle special casing for different browsers is the probably unfortunate reality of our platform at this time. And that really stinks, and we all know that we need to do better. But you will find quirks that you need to apply for Safari different than, say, Chrome, that are different from, say, Android, the old Android web view or something like that. So I would plan for the possibility of needing to do that. How are we doing? We got probably one more question.
1 minute, so one more question.
Especially as we're long-winded.
Hi, you talked about permanent vigilance. Can you tell us how Google internally spots these, whether you've got automation tools to assess when things have got worse so that we can not depend on developers being vigilant because they're going to be distracted by other things as well?
Sure, yeah, Nat built some of them. So
Yeah, so what we use, we're starting to use, go Google Chrome telemetry. It's a framework built in Python on top of DevTools protocol. So DevTools has this fantastic JSON level WebSocket and then JSON level protocol where you can talk to the web page out of process. And you can build developer tools on top of it. You can also build fantastic profiling tools. And you can get out of the timeline stream in that the painting info of what was painting. And you can then build all sorts of cool stuff on that. One of which is telemetry.
So that's the harness, and then we have sort of collections of web content that are sort of interesting cases for whatever reason that we're worried about improving performance of or regressing performance against, and we run sort of banks of that content with this harness, and we have like performance waterfalls.
Yeah.
So
Thank you.
Hopefully that is compelling.
Well, thanks everybody so much for coming.
Yeah, thanks
good
again.
luck dejanking.